Right? Example 10 says, let Y represent the mass of a quantity of a radioactive element whose half-life is 25 years. After T years, the mass in grams is, and this is the equation, the formula for it, okay, where Y represents the amount of the radioactive element, and T is the number of years. What does it mean, half-life? What is a half-life?
How long it takes for half of a radioactive sample to decay to a stable sample?
Right. Well, it's how long, it's amount of time. Half-life is an amount of time it takes to decay to 1/2 of the original quantity, right? So how do we calculate an initial mass? What would we mean by initial? Josh? Okay, what would we plug in for T? For initial. What is 0? An initial amount means the beginning amount. So you want to say T equals 0. So in this formula, if I plug in 0, I'm going to have Y equals 10 times 1/2 to the 0 over 25. No. That is 10 times 1/2 to the 0. But what is anything to the 0 power? It's 1. So it's 10. So this number here, that if we were graphing that, we would have called that a vertical stretch, right, by a factor of 10. That number is the initial amount. It's part of the formula right there. Remember, that was the half-life. So you can kind of see where that comes in. Okay, so when they say initial, that means you substitute T equals 0. But if you're given a pretty standard exponential function like that, it's always the stretch factor. It's that constant that's in front. Okay, how would I find the mass after 80 years? Right, put in the 80 in the place of T here. So Y equals 10 times 1/2 times 80. Oops, that was not good. Over 25. And that is 1.088 grams. So have you guys done this in a chemistry class maybe? Okay, so you already know this stuff. You're expert. We can have these problems all the time. Okay.